Morning. So I'm getting my things together here to start the work. Getting my browser up, my editor, the streaming thing. So where are we? So I was going to start doing showing off some of the well, first I wanted to do the Wolf SSH backend stuff because I have an idea how to proceed, and then I wanted to show off a little bit about the how the parallel transfers thing is looking now. It's actually pretty cool. So since I showed off when we started doing parallel transfers on the stream, was that the last stream? Oh, well, some streams ago. I think it was the previous one, right? So I continued on that path a little bit after the stream was done. So I wanted to show you a little bit how fun it is right now. So here, well, here are all my files in my Emacs. That's not too fun, but I wanted to show you how it looks right now if you want to do an excessive amount of parallel transfers with curl like this. Okay, here I'll just get my parallel transfers Git branch. I'm going to build it. It'll just take a minute. Fresh coffee. So okay, to do a lot of parallel transfers, of course, that's I wrote up this little example that makes, I think, 100 options or so. 100, not options, URLs, 100 transfers, I think. But to write them on the command line, that's really annoying, right? So I wrote them all in a little config file like this, and they're separated like this. The URL to download, where to output it, the URL to download, where to output it. And as you can see, I basically just download the same thing and output it to dev null because I just want to try it out. I don't want to actually see anything. And then in the end, I actually added a 3 GB file over SFTP just to spice it up a little bit. And to do this with curl, you can do it like this. Start curl -capital K, specify the config file, which happens to be this config parallel, which is the file you can see on the right here with all the fun URLs. And then there's the -z or z, in the capital one, and there's I'm not sure if I'm going to spend a single letter for this or not, but okay. And then I've added a new option called parallel max. And this basically tells how many transfers to do at the same time, at maximum. So in this case, this config file, it has 202 lines and 2 lines for each transfer. So here we have 101 file transfers. And with this command line, I ask curl to only do 36 at a time. So how do we transfer all these? Well, I just enter this command line and I press enter like this. Boom. And then you can see that there are live, that's the number of live transfers. QD, that's the queued number of transfers. You can see the queued number of transfers going down pretty rapidly. And there are no queues anymore. Lives starting to shrink too. Now they're completing. We've downloaded 43 GB, and the download percentage goes up there. Why is it so slow? Something is weird, but okay. I might have something else in my background. It doesn't really matter. So, bam. That was 101 transfers done in 41 seconds. Yeah, that's how it looks. So this is a completely new progress meter for parallel transfers. I mean, it's not written in stone yet or anything. This is what I've come up with so far. What is interesting is that we don't have this percentage of the download percentage. We can't say a percentage until we have, until every download is known, until the size of every download is known. Actually, until the size of all the remaining downloads are known. Oh well, I'm sure there are still some gaps or improvements to do. So, but that's why we only see the download percent get updated here once there are no queued ones anymore, because as long as there are queued transfers, we don't know how big they are going to be, so it can't estimate the download percentage, and it can't estimate the time left either, because we won't know how much data. So if we look at it again, just start over and let's clear the screen and start over. Here's why it doesn't say any percentage for download, and it doesn't say any estimate for the total or estimate for time left, because it doesn't know, right? There are still 37 queued, 29, 18, and now once it's no longer queued, then now, bam, it has information about them, so we can, it says that it's estimated 20 seconds left. And it suddenly turned very slow. I'm not sure. I wonder if I messed up something. Well, I'll ignore that for now and pretend it didn't happen. And then, bam, done. 100% download. 52.7 gigabytes. It's pretty cool. And then, as you can see, it works rather solidly too. The discussion I have now on the mailing list is how to report. What if one of these transfers failed? How do we output this, or how do we return it? What if 2 fails, or exams, stuff like that. It's a bit tricky to come up with a really good approach to do. And this pull request is here again, 3804, and I pushed, I force pushed it. Better update here, because I force pushed it 11 hours ago. Oh, there we can see. So it's I like when Travis is green, at least. The Travis build at the bottom here, that's probably the most important CI build. So yeah, when that is green, that is a pretty good sign. AppWeigher is probably the second most important. The coveralls we can basically much ignore, because it goes bananas too often. So it's, yeah, it says coverage decreased 1.9%, but it's most likely just being crazy and wrong. So let's ignore it. In AppWeigher, we have a lot of flaky tests. That means that they basically fail every now and then without good reason. So we very often just have to see at the end here, we can see which tests that failed. It says like this: these test cases failed. And I recognize these 1501 and 1592 in the 1500 series. They basically are the ones that are flaky on AppWeigher. So I rerun the incomplete ones. Asking AppWeigher to just rerun the ones that fail. So it'll just run those again and just verify. They tend to work the second time when they're this flaky. So they'll have another attempt. So looking pretty good, actually. I squashed a lot of tiny patches and rebased this 11 hours ago, so yesterday evening, just because Jay provided a few fixes and I did some fixes, because after my recent edits, I had a whole bunch of minor warnings on some platforms, and so on. Like, I accidentally did the comparison with signed and unsigned, and I did some other just minor type things that my compiler didn't warn about, but other compilers did. So now then, let's save the parallel thing for now. I merged another pull request this morning. I merged this thing. I think I discussed this before. This max input length. So now, starting now, curl will actually limit the size of strings it accepts. So it'll only. So when you pass a string to a libcurl argument, or when you pass a string to curl easy setup and curl URL set, it won't accept strings longer than 8 megabytes, or actually 8 million bytes. Just to avoid mistakes, issues, abuse, and things like that, because usually, or we can't really think of many actual good use cases when you want to pass on a string that is longer than that. The limit is very arbitrarily picked, but it's put there as a safety precaution, really. Anyway, where am I? So I'll out of the issues I had with Wolf SSH the other day when I worked on the back end, one of the only one that isn't fixed yet in the Wolf SSH Git is this. I filed this issue about SCP and SFTP build errors with GCC 8.3 because when I build Wolf SSH out of the box on Git master, I get these compiler errors that if you were around when I did it the other day, you saw them as well. And they're on top of that. But since they haven't merged that fix yet, I'm not going to update to their latest master either, because I already had this lame fix in my end. So I'd rather stick to my version for now. And once this gets merged, the 160 here, when that gets merged, I'll update to the latest Wolf SSH Git and go from there. So I am at this state here. I'm I also talked to John Safranek, who's one of the guys working the most with Wolf SSH, and I now have I now have an idea how what I should do to get myself a step further. I'll just rerun build conf to get my configure file updated. And just as a reminder then, I have Wolf SSL installed here, Wolf SSH there, and actually Wolf SSL, because Wolf SSH depends on the Wolf SSL library, so they are both there, right? There they are. And I built both of these from source. I installed them in these, and when I build curl now to use them, I have this little script that sets up the include files to find Wolf SSL, to set the R path to find my custom built libraries when I run the binaries, and then I run configure with the new option with Wolf SSH and point out my custom build, and then just the ordinary curl flags to enable picky options, enable maintainer mode, that's an autotools thing, and disable shared libraries because I want to build a static libcurl just because it's easier to run debugging on it and view symbols and stuff. So I just run this script now, since I rebuilt my configure, and now I will build with Wolf SSH. Okay, got distracted there for a second. Okay, so now I rebuild with Wolf SSH enabled. Just going to verify it. It says Wolf SSH 131. You can already build curl to use Wolf SSL if you want to, so it's just a matter of a build option. And Wolf SSL works really well with curl. There's one test failure, but that's only because I haven't done the necessary fixes, or someone hasn't done the necessary fixes to fix that little thing, because it has to do with certificate revocation, which is well, rarely used, so it's not affecting many users. But okay, here we are. So Wolf SSH, this is the code, I believe. Just going to reload it here to see that we're good. And what I probably didn't show you, or maybe if you went around, I think I built Wolf SSH with extra debugging options on, so I would be able to get some extra SCP test, sftp:// SCP test. That's my user on localhost. So if I do like this, I will connect to SFTP with this username on localhost, and I'm adding -v then for verbose, and it's supposed to work. Boom, but it doesn't. And I just wanted to show, I haven't addressed this problem yet. But this is now the Wolf SSH extra logging thing that I have enabled. I can enable it with this line of code, and this is the documentation for this function says that it only works if we actually, I mean, it doesn't do anything in a normal build. In a debug build, it switches on debugging or logging, and that is what we're seeing here. So that's pretty good. I get some good data here. I think in my case, I was mostly interested in this, which says that it was a wood block situation, and that is fine. And it turned out to be that I didn't really understand the API properly, so that is what I'm going to address now. I think I'm going to see if if I learned something, if I figured out the API the right way. This is the function call that fails here. Wolf SSH connect. Entering, that's the function we enter, and it returns there -1001, which is actually the fatal error, or whatever they call it. They have, I think it's called fatal error, but there it is. General function failure. But now then, if I understand this correctly, when we get that error, we want to do this get error thing to extract the actual error, like all of these things. If there was an error, ask for the actual error, which looks very OpenSSL inspired, like this. If RC isn't success, get the error out of it. Maybe. Or maybe not. Ah, right. I copied a little bit too much. That has to be the session pointer. These warnings are fixed in Wolf SSH master now, because they changed. This is a warning about an enum, and it's being changed to defines now. So when I upgrade later, these will vanish. So if this works much better, right? Exactly. Now it works much better, and Wolf SSH connected. So pretty good. We got password authenticated connection done. Well, to the SSH level. And SSH, of course, then you have to start the SFTP sub, what's it called? The sort of a sub protocol within SSH. I don't remember the name of it. But so I need to do, I need to make sure that we do the correct thing to start SFTP as well. We can see here that internally here in curl we change state in the SSH state machine from startup to SFTP init. So now it basically detected that we want to do SFTP, so we need to enable SFTP as well, or init SFTP. And we do that with this function call in Wolf SSH called SFTP connect. And that too can return would block. Of course, most functions there. I mean, they have an non-blocking API, and we have a non-blocking API. So it's important for us to know that if we would block, we need to return and wait until there's data to read or write. So if it wasn't success, we get the actual error code, and here we want to do pretty much what we did there, I think, like this. If it's want to read, then we block. It says we want to read something, and we return OK. If we want to write, we block, and we want to we want to send something. Yep. Ooh, right. And when it returns success, SFTP connected. Ooh, let's see what happens. yeah, it worked. So I have been told that my audio is not quite synced with the video on my screen and stuff like that. So, but I'm going to ignore that for now, I think, because I'm not sure what exactly I can do about it. So I think I'll check out my settings later and see if I can do something about it or not. I guess you can pretty much ignore my video. I mean, the video of me anyway, and then it doesn't really matter if we're in sync or not. Maybe. Oh, right. So we have SFTP connected. That's pretty good. That's not too shabby, right? So we have SFTP connected. Now, let's go over to SFTP. I'm checking with the regular libssh2 state machine because that's the one I'm most sort of familiar with. Oh right, it figures out the real path, get the home directory, and now I need to switch over to Wolf SSH API docs. I don't remember where I found them. No, not Wolf SS. There, user manual. Oops. That's not what you want. Ah! They're on wolfssl.com. Ooh. I'll just... I don't know. I'll just ping someone about this. It's weird. Why is it a 503? Varnished. Yeah, this is something. Has to be some sort of proxy here that talks to some backend with a certificate that has expired, because I mean, it's connected, right? So it's not the actual side here. This is fine. Well, it's not entirely unthinkable that that we might get different responses, but it's probably a back-end thing. So it's yeah. Oh well, I pinged someone in wolfSSL about it. So I am not at all sure how this works. No, it's not that one. I wanted to... I wanted to see how the documentation is generated, because... Oh, it does. Maybe... So So why does Chrome do that? Because it says in my case it says expires next year, so it's not exactly 3 months, but 9 months. And it's Fastly, so it's so I mean the wolfSSL.com thing, that should really work, since it's a Fastly thing. It's not even wolfSSL. So if that doesn't work for you, it's funny. And Fastly is what we're using on curl as well, and that works fine. Let me check that. That's what it says there. It says more information. View certificate. Almost the same thing. Well, a little bit later and a little bit longer, but still. Expired yesterday, according to Chrome. Okay, then, but let's ask someone we trust a little bit more, right? So we go here and we do curl dash v http dash v https wolfSSL.com. Oh, right, it's the old curl with that silly thing. Let's run the latest. Boom. Yeah. Yes, it doesn't like it either. Failed HTTPS connection. So with -k, there it is. It is expired. So why doesn't my Firefox say so? My Firefox seems to be the only one that can connect to it right now. Why is that? Seems like a bug, right? Well, you shouldn't do that. Strange. Well, oh, on Chrome too. So okay, yeah, but then I suppose we're getting different machines or something. Since I mean that's a Fastly CDNs, right? So we're getting different. In my curl case here, I got. Well, it's not easy to know what. Which one did Firefox use? So if I go here, reload, check, refresh, there it is. That's the one, and it's not at all the same. So hard. Okay, so let's switch over here then to the one we get is outdated, but we want to use wolfSSL.com on port 43. We want to use this address instead. Boom. And if we use that address, it expires in October. So if we use that address, we don't have to use -k. Sure, something else is wrong. How weird. Oh, it's not W, it's there it is. See? Then it works. Exactly. So it's a Fastly thing. Some servers seem to have expired certs and some don't. And apparently, if you happen to connect to this, there's just a backend. Not that it helps, but you get a different kind of error. Uh, and right, funny. So the if I ask for without www, I get a different certificate because then it expired in October. But if I use www, I get one that expires in January next year. Okay, that was some totally unrelated SSL debugging. But it's in the way of my understanding of the SSH API. So let me instead then read the include file and blindly guess how things work. That always works out excellent. So I want to see the SFTP API. Well, alright, I can just look at go back to the SFTP client example. SFTP client example. Here it is. There's an SFTP connect. There it is. After the connect, connect. Yeah, non-block SSH connect, which is in fact an SFTP connect. But okay, that is fine. After that, it does this. It real path. Get current working directory. Which, yes, that's what we need. And it looks like they've been inspired by some other SSH libraries, because now this looks very familiar here. So we switch to the real path state when we've initted, and we figure out the real path. And here again we need to do this dance when we want to return, or we don't want to block. So actually, I think my journey into wolfSSH patching here turns out to be a really good way to test things in the API and in the wolfSSL infrastructure. So instead of go to stop, we go to SFTP real path, wasn't it? SSH SFTP real path. Real path. Yep. And then we add a state for that. We want to get that one, but we don't want it to be like that. This is fun. I guess that is relative or something. I mean the relative directory from where we are. We want to know it from where we are or something. Okay. Let's ignore that for now. I think this is interesting because it calls the get error unconditionally. So let's do that as well, because then it's apparently good enough. We want to have the SFTP name. Maybe we can have that a generic one. Name. So if feels like this is becoming a pattern, we should do something better. So if it returns read, we return blah blah blah. If it returns want to write, we will do that. Right, and if it returns success, we are real path. If we get success, real path got. I'm adding a lot of extra things here so that we get some logging just to follow along. We can strip out part of that later. Maybe shouldn't stop the state machine there either. So this makes a malloc blah 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 mem copy. So not a string copy, it makes a mem copy. So apparently this is not a zero terminated name, which is inconvenient, but let's just deal with it. So in this case, there it is, home deer is what we call it. This string is not always null terminated there either. So it's okay, but that's a different. So let's call it home deer. Equals, and we allocate how much. We allocate that much. That is the length of the name plus 1 for the 0 bytes. So we allocate it. If allocation fails, we're in shit. And what do we do then? Actual code. Let's just, the error paths we need to work on later. So we allocate it, and if we allocate it, we can copy the name from there that long to this destination. There's the name, there's the length, and we zero terminate it. Ooh, I wonder, we do have, I think we have a memdup function somewhere, don't we? We do. That's a pretty good function to use here. Except that, no, because we want to add a 0 afterwards anyway, so we we don't want to dup the memory, we want to dup the memory, add 1. Okay, so let's not do that. Let's just do this mem copy and home deer, and at the name fsz. I'm not a fan of these weird this naming convention, but who cares? SSH was wrong. It's supposed to be SSH session, or what is sftp.h real what's the yeah, that's the session pointer, and And I'm so sloppy, I do so many just of these stupid mistakes that I have to walk through and find. Has no member FSZ. FSSZ, was it lowercase? No, something else was wrong. Okay. Picky code style, but I like it. Then we try it again then. So how far? Oh, that's not the command line we want. Here's the one we want. Segmentation fault. That's not exactly what we want. But at least we got sending real path, blah blah blah. And if we run it again, it'll crash on that because name is 0. And RC is 0. That's interesting. Unexpected SFTP type received. SFTP connection not complete. That also sounds weird, doesn't it? The good part with having so much of this debug data is that from wolfSSH is that when I run into problems, I can talk to the team there, and they have a good idea. They'll have a good idea what's going on, and they might be able to help me out later. Why? How can this become 0? And here's what the lack of docs online right now gives us, because let's do this. Let's read the code. How hard can it be, right? So get me the code. SSH source SF wolf SFTP. Yes. Real path. There it is. We should only do this if we actually have a name, and then we will avoid the crash, but nothing good will come out of that anyway, since beep. Yeah, because now we get to this point, so it just stops and returns an error. Just wanted to verify, so this is when I run the normal curl, and this is the curl in my Debian installation, so it's 764.0, and it uses libsh2. Just compare that it actually gets the path correctly. Okay. I'll check out the libsh2 backend. So when it's done, it goes here. This is pretty much all it needs to do from the connect phase for SFTP. This is the last step in the connect phase, so it goes to the stop state in the state machine. Because then it'll do, when it then instead goes to actually fetch a resource, it'll do, what does it do? Right, that's the do it function. That's the one that the do. And do the transfer, do the request. So then it'll do this. Setting up a bunch of things, upload counters, download counters, blah blah blah, and then depending on which protocol it uses, it goes to the perform function. So since we're talking SFTP right now, I'm going to look at it. So it will just set the state machine to the quote init state and run it, and it'll just run it until it would otherwise block, and then it'll go back. Unless until do phase done is set true. It'll keep on calling this function actually, which seems wrong. No, right. It'll. What will it do? But now I don't get the real path back. How annoying. Let's check again how it looks. Okay, let's do this then. Just as a weird and silly workaround, if it works and we didn't get a name, I wanted to do a fake name just to get us past this point. It struck me also that I think I need to, yes, I need to free the name after we're done with it. Here. So let me do like this. I just want to see if we can get past this point. Or not. So if this, if I can actually maybe do, right, now it succeeds, but it's fake. Fake succeeded. And we check the do it. It's called SSH do, the do function, and I think we have the same. Since I copied everything originally, we have a, that's the one, WSSH do. Let's keep it generic for both protocols here as well, and I'll just copy the entire thing here from the libSSH2 backend just to get us going. It'll set up a few things, blah blah blah, and we can have these perform functions. They look fine. We don't have any prototypes for these functions. So let's do that. Let's make it not do anything. Since we start with SFTP, the SCP just will be a stub for now. And here's the one we want. And it should be a W in front of it. WSFTP. So there's an SFTP perform in the libSSH2 backend. It looks like this. I'm going to copy the entire thing. SFTP perform. There was once, I think, a server called WSFTP, right? Wasn't it? Good. So we have this fun quote system, which just basically a list of commands to be able to run before the transfer starts, inspired by the FTP system we have. That a long time ago we added just a linked list of FTP commands to run before the actual transfer starts, and we have the same thing for SFTP as well. But of course, SFTP is a binary protocol, so it doesn't actually just run the commands that we tell it to. So we have to interpret what the user asks for and do that. Which is a bit of annoying. Quote SFTP quote init colon. There it starts. So it's quote init, and if it's something there, it goes to quote to actually send the commands. Otherwise, it goes to get info. SFTP get info being an extra set of braces that aren't needed. But okay, if it checks here, if it wants to get file time feature, then it asks for the modification time of the remote file before it does anything. If not, it goes straight to trans init, so which is then the setting up the initialized stuff for the actual transfer of SFTP data. So back again there. No, not the next quote, the quote init. And curl get working path. What does it do? Alright, it tries to figure out what path to work on based on these funny things. So I think we can, for quote init, I think we can copy the entire thing. You can copy even the case here. We're copying the entire thing into the wolf SSH. Where's the state machine? I'm lost already. I haven't done much in the code, but I'm already lost. So I'm here. Bam, new state and the state machine, where it'll need this now. SFTP SCP path. SFTP SCP. There. Actual code, blah blah blah, sending quote commands. If not, it'll go to the next state. And this is safe because I'm not going to try any quote commands right now, so it doesn't matter if it switches to a state that we haven't implemented, because I'm not going to try it right now. Implicit declaration of course, because that's another file I need to include a header for. Curl path. And no warnings. With one warning. Undefined reference to. Okay, didn't. I think I know why. Right. Here's a chance for me to do this new thing. Like that. No. Because use wolf SSH isn't okay. Because it's set there, right? Use. Wrong place to set it. we should set it in curl setup that .h. Here is where we set up those things. Other use things are set up here. Boom. I'll admit that the should I ever rewrite it in Rust question, it gets a little boring at times. I mean, it's fun to joke around about from time to time, but sometimes I don't even bother to joke about it. No, I'm not going to rewrite anything in Rust. But go ahead, feel free to do it. Right, now it's yeah, I need to save some goodies for someone else to work on. So the converting curl to Rust job is I saved that goodie for someone else to work on. Now I wanted to make sure that my state machine for curl moves on to actually issue the request, but it doesn't look like it does. So I'm going to state do. It doesn't seem to actually reach the do state. It's supposed to be done in the proto connect. A lot of logging from wolfSSH at least, so it's hello. I get lost in all the what's wrong here? State it says it's done if the state reaches stop. Connecting. Okay, so I'll set a breakpoint somewhere in here to figure out what it does. Or I can do it like this, by the way. I can debug. It's very verbose, that one. So if I switch off the SSH debugging for a second, and maybe if I switch off that one as well, that didn't really help us much. But it looks like some sort of bug because we shouldn't spin that much. So let's keep that in mind going forward. Do receive, why, who says that? Oh, is that my... I think that's me doing things in wolfSSL that I really shouldn't. There it is. stupid. Well, not stupid maybe, but... So I need to rebuild this. And now I need to remember how I did it. I did like that. And I'll make it easy for me to save that as my make. Like this, my make. Good to do, to remember what the heck I did. E. That's not what I did the last time. Did I mess something up? Undefined reference to. Build the. Sorry. Not like that. Make clean. Sorry. I was supposed to do my make. And my make, I think, should also have that one. And now, my make will do the right thing. It actually adds -J9 on by itself, which is interesting. So, rebuild curl in curl directory. Right, it doesn't ever leave protoconnect, so it doesn't consider itself done. So let's figure out why it doesn't do that. Protoconnect is here, so it calls the protocol connecting function, and that only calls the connecting, passes on the done and hopes that the connecting function sets the done. And in connecting, that's the callback function, this. If done, this, I'm just adding some fprint here to verify that this doesn't actually happen. Nope. Well, the fake succeeded, so I think it's something wrong with the fake. But why so? They changed the state to stop. It says even so. GDB to the rescue. If I put a breakpoint of 503 and I run, and there I display SSHC state. It got stuck in there. On what? While one. Oh, there's a while loop. Wait, what? Okay, yeah, we need to return. So in the case of everything look great, return in the actual and in the fake. So I think that is what we need. Yeah, that's good. Then we got to the next state in curl, because that's the do state. Do being issue the request, so the do phase starts, and then it does this that we added, and it got all the way to SFTP get info, which is exactly the logic we copied. I copied. That's great, because now I'm going to implement or copy at least the get info state. The get info just changes then I can remove the extra braces because we don't need them. So, and let's not try out the get file time feature right now. It'll just require an extra fetch from the SFTP server, so it goes straight to the SFTP trans init instead. Transport init, like this. And in transport init, it will either go to upload init if we do an upload, or complicated, check if it's a directory we're gonna read, or if it's a file we're gonna read. And you know, directory mean that's if you end the URL with a slash, that means you're reading a directory, because we have no other clues. So that's a rather kludgy way of figuring it out, but we've been doing it for a while, and it actually works pretty good, and it's documented, and then yeah, that's how things are. So in our case, when we do this command line, it ends with a slash and starts with a slash, but it's a directory. So let's it will go then to the read dir init. So let's focus on the directory path. There it is, the read dir init, read directory. And of course, this is very, very SSH library specific, so it depends on how this works. And now I have no idea how Wolf SSH works in this aspect, so I need to read up on this. So if you come here and you set the no body option, it stops, because then you asked for no body to get transferred, so it won't transfer any body, which then the contents of the directory will pretty much be. So this is a directory we're trying to get, so produce a directory listing. Yes, as FTP is a very binary protocol, so it doesn't actually produce a directory listing. It is more of a file system level thing. We get packets with data about the file, about the directory, so we need to get the data, interpret it, and output something. So SFTP open. I'm just going to remind myself how it looks. It allocates buffers. So it opened the directory, and then in read dir it basically reads and writes Oh yeah, it has several other states for fancy things. And read dir bottom. yeah, reader bottom is the one that actually outputs stuff, and then it goes back to the reader state. So reader is the kind of primary state for reading and reading directories after it does the reader init. So reader init. Back to the header file. So is the I assume that we can't really hope that they actually fix this short term. No, the bug is still there. Hello. Very, very, very annoying. Okay, I guess it's just a bigger challenge for me then. Here's an open dir. It takes a buff and a size. And there's a read dir. There's an open. Okay, maybe the example might help us here. SFTP client. LS. Is there an LS implementation somewhere in the SFTP client? List, maybe? SFTP LS. That sounds fun. Working dir. That seems to get an entire directory, does it? As long as it's really hard without documentation. What is this? SFTP F puts. Some sort of callback. Okay, there's just some output function in doody-doo-dee-doo-dee-doo. So what is the working dir? That's the one we're figured out. Yes, that's the home dir. So we can. So, hey, why not? We're not that difficult, right? We can try it out. SFTP name. That's the name we already have, I think. The variable we already have. SFTP name, yes. So SFTP trans init. If the read dir init here, we wanna do it. We wanna do it, which is the ls function. Pretty much this. What does it return? Current. Current. SFTP ls returns current. Returns the name. That's weird, isn't it? Or maybe I'll just have to figure it out. And it returns this error thing, which we take as an RC thing. Because this again is non-blocking, so we need something like this. Boom. If it wants to read, we block, we wait for a receive. If it wants to write, we block, we wait for it to send. If we get a name and we returned OK, we're good. And in that case, we probably have something to show. It looks like it might get one name at a time. What does it get? It outputs difficult. Difficult. Let's output. Oh, look at this. It's a linked list of names. It returns a linked list of names. Oh well, 1.5 hours. I think I get the sense that I need coffee, and just a short walk down the stairs to my kitchen, fill up my cup, and then get on to the SFTP directory listing. Maybe we'll get an SFTP directory listing soon. But first, 1.5 minutes for a coffee refill or something like that. Okay, hang on. Yeah, and I'm so very happy with my coffee pause screen thing, so I need to use it at least once every stream, right? So you can see all those weird curl products. But okay. SFTP directory listing. That's thrilling, isn't it? So yeah, will this work this time? Or is it going to be another case where I need to do something fake? I'm going to just do this to start with. Name. Name, F, name. Wild name. We know there's a name here, but okay. Name is name. Next. And afterwards we do the wolf SSH SFTP name list free name. What could possibly go wrong with that? Again, SSH session. And working there, that's not the name of it. It's called home dear. Or what is it? No, it's not. Let's check out. I think it's that path. That's the path. Maybe. It's a little bit annoying, this warning, but it should go away later. Okay, so what happens now? Does anything work, you think? Or will it just crash and burn? Boom. Nothing happens at all. Well, let's put back the debugging thing for wolfSSH and see what terrible outputs it will show us. Boom. Well, a lot of looping there. I think it's because we don't catch the error, maybe. Here. If it returns we want to read, we do that. We want to write, we do that. If it's success, we do that. But if there's a failure, it would end up here. And we don't catch that yet. We better do that because something is wrong here. So we do boom. Oh, right, it should also end here. Basically. Maybe it did that, but I didn't see it. Okay. If we just it's a bit of it tough, but let's SFTP ls failed. Something like that. It failed. And no documentation. That's a good URL, but no certificate. I would imagine that this then maybe we do the same thing in libssh2, so it returns what does it I'm trying to see how we do the for libssh2. We can have the list only with which only outputs the file name, which is fine. That is what we do. Also, we also need to do exactly like that. And if it's not FTP list only, then we need to create ls looking ls style output out of the data that we have. So we need to extract data about the file name. We need to figure out the attributes, the size, and this stuff. But I'm not sure how to do that in Wolf SSH lingo. But okay. Okay, let's dive into this instead. We are asking for a file instead. And in my home or in my TMP directory, I'm going to put a file just like this, echo hello 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 into TMP hello. Oh, into, not like that, like that. So my TMP file hello contains that file. So if I get it over SFTP TMP, well, in my home directory, so it's supposed to be like that, and hello. Will it work? Well, not like that, but if I would do it with a regular curl, it can't open the remote file for reading because it's in it's another of course, because I need to do like this. I need to log on to the test machine as SCP test. And in SCP test, I need to do something. In the home directory, there's a 3 GB file, and we can do hello, hello, hello into hello, and just keep it in the home directory. And then we should be able to do that's hello, hello, hello. So that's what we want to be able to do like this too, but we can't. Says done, yes. Okay. So I'm going to go back to the state machine. So it'll then go to the download. It doesn't, now the URL doesn't end with a slash anymore, so it's not a directory anymore. Now it's a file. So it'll go to the download init state, and we don't have any download init state yet. But why does it say done? Okay. I'm going to also switch off SSH debugging because it's in the way. Now I'm gonna want to see that, oh, -v as well, so that we get some there, SFTP download init. That's what I wanted to see. So we go to the trans init. Here it goes to the download init. So we do that here. I'm going to again compare with work on getting the specified file. So it basically just opens the remote target file and change to that state, download stat. We don't need to have the exact same state machine layout, but I think it's convenient. And then it handles resume or ranges, so you can download just a range of the file even with SFTP. And then you blah blah blah, a lot of error checking and set up things for the data transfer. Here are more things for data transfer, and then should never occur, and then it actually goes to the stop again because that's the end of the do state in curl. Then we have issued the entire request to get the transfer going, and when this ends that state, and then it'll go to the SFTP perform next. So we'll see. Here we are. Download init. Case SSH SFTP download init. Time to guess on the API. How do you think it'll work? There's a read. No, that's the server function. Server functions. Could be get from to resume. Look at the example. Right, there's a get command in their example here. I think that's useful. SFTP get. So it's callback based somehow. Very protocol-ish. So we get the data as 64 bits and we need to shift it around. This looks very I mean, it looks like we're getting it from the protocol somehow. But why do we do it? Why doesn't it pass on as a word 64 immediately? I'm a bit scared that this isn't in the right byte order everywhere. But how would I be able to tell that? I'm not sure yet. Let's wait and see. Or nah, I can check out the code later. So it delivers the data in a callback. Long bytes processed. So yeah. Processed. Get. So that's the command line get. Check if the local file path. Check if local file path listed. Right? So you can get something into a local path. And you can, and it can resuming blah 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 to as I don't get where the data comes. Was this status callback? It doesn't seem like it actually delivers the data. It seems to delivers information about the transfer, not the data. Well, I guess I could just implement the first part of it and then I will figure that out. From to. I don't like the look of this. What to? So I read the code anyway. Continues a loop over SFTP read. Stored offsets are searched for from to can be null, but if not null, then callback function called on each loop with bytes written. That's what we want. That's the one we want. I guess. Oh, let's look how they're doing it. Something like that. From. It's a bit hard. This is directory. What do I call it? From. I think that is the path. And we want to read it. That's the reason. Attributes. Yeah, we want the attributes. And let's call it at for one. And then a handle. Pointer to a handle. Word 32. That's the length of the handle. Okay. Good enough. Comparison time. Path. Length of the path. Time to read. Very similar. File permissions. Oh, that's the file permissions when creating a file and we're reading it, so we don't need any permissions. And it sends an open file, but we pass a pointer to a handle. What is a handle? Oh, there's a. Oh, right. It's just an opaque thing, isn't it? I'm going to read the code again. Here it makes an open state handle. A state is just that's what it gets. This handle and the handle size. Max wolf SSH max handle. So let's see if we can do the same thing. We should rather do the same thing. If I only need one handle, I can do it like that. Right. And I get the warning many more times. And let's call it SFTP handle. Maybe it doesn't matter. Very annoying warning there now. But okay, it passed through, so now it actually builds. But what does it mean? Not a lot. It opens the remote file. which is a good thing. Open the file if it doesn't run. And we do the same sort of logic we've done before. Because it might block otherwise. If it gets to this point, it's supposed to be end of the do phase, but it's not quite, right? So let's just see what. See what happens. Segmentation fault, yeah, that's some sort of progress. Where on the 4. Well, I'm looking at the example code here, right? But the SFTP client, example, it uses this as more higher level command for SFTP get, and SFTP get, this function apparently downloads that file into this file, which isn't at all what we want in the library. We want to get the data so that we can, pull it into curl style, and therefore I'm looking at the implementation of this command, which is in. So I'm looking at the implementation of that command, which looks like this. No, where is it? Here it is. And in this function, we can see that to actually open the remote command, it uses this SFTP open, which I think this makes perfect sense. So this, it makes the open call. So I want to do this, and once the open works, read the contents of that file. This is opens the remote file. So this is what I'm trying to do now, to make sure that I can open that and then ask for that file contents to get delivered. And it makes that's pretty much exactly how the libssh2 library works as well. So it should be fairly straightforward. But apparently it isn't. So something is wrong. // hello. Oh, / hello. I wonder why it's. It's interesting that it's segvs anyway, because I don't think I'd do anything that bad. Wolf SSH handle, directory, reason, attributes, and attributes could apparently be 0 or null actually, which is what we're passing in, and then a pointer to handle and this pointer to the handle size. I think that is what we're doing. But apparently that's not quite appreciated, unaligned. Wolf SFTP 4292 mem copy. SP buff p local IDX size optimized out. I thought I built with maybe it doesn't remove dash capital O. I wanted to build without optimization, but okay. It copies make sure is null terminated string. English. Okay, but that's not good then. So what's wrong here? Well, we don't know how much it wants to copy. Enable the SSH debugging. Boom. No, this isn't good. But it was bad already when I had to do this fake thing. So maybe that it's all related to me not doing things the right way. Okay, I need to take a break and get some lunch and eat and ponder about my code. And consider what I'll do next. So I will just end the stream now. And I think I'll be back again tomorrow. Maybe. I haven't really made up my mind yet. But not that much progress today. Okay, I did some fun SSH. Came a little bit further. I will talk to some of the SSH guys maybe and see if I can figure out where my issues are. See you around later. Bye.